Now we'll see access method in Ethernet. Access method in Ethernet is exactly equal to CSMA CD plus backup algorithm. That means, so sensing is CSMA and collision detection is CD, and you know the procedure of CD, and backup algorithm. Whenever there is a collision, then we apply backup algorithm. You know what is backup algorithm, but let me consolidate all these things. So finally, so I'm going to teach you access method one more time, but that is nothing but CSMA CD plus backup algorithm. Let's see first of all. First of all, we have to sense. How to sense CSMA? In CSMA, and especially there are three techniques. Did you remember? So CSMA can be implemented in three ways. How can we sense the channel? Three ways. One is, one persistent technique. Second one, no persistent technique. Third one is P persistent technique. But what Ethernet uses, sir? One persistent technique. That means every station starts whenever they have data, especially whenever they have data, they will sense the channel. If the channel is free, immediately they will send. That is what one persistency. Okay, so immediately we will send whenever you have data. But what if this channel is busy? Keep quiet, keep on sensing. Understand? That is one persistent technique. Suddenly one day what happens? You will see that channel is free. Whenever channel is free, simply send. Right? Similarly, all other stations also apply the same technique. Okay. So that's why. So there might be collision. Whenever collision occurs, right? So how you detect? For that, we have minimum frame size. Since we are, sending at least uh, 2 into propagation delay transmission time, correct? This much transmission time. So definitely if there is a collision, we can detect. I told you that procedure. Please refer CSMA CD, correct? So we require at least 2 into propagation delay of transmission time. Now, once you detect, what are you going to do? So according to Ethernet standard, so let me introduce a signal called jamming signal. I will tell you the meaning of jamming signal and why we use it. Whenever there is a collision, so every station who detects that collision will send this jamming signal. Try to understand. Whenever there is a collision, whoever detects it, usually they send jamming signal immediately. Okay, let's see the story. Example, station A is sending to station B. Why always I take station A here, station B? Because that is the worst case phenomena. So remaining cases you can understand. Example, C is sending data to D, then you can understand it easily in the same way, correct? So now A is sending his data. Since his minimum data size is definitely enough, so that is more than, that means the transmission time of the data is more than 2 into propagation delay. What is going to happen? You see, I am talking about the first bit. That first bit is going like this, still no accident, no accident, no accident, no accident, just now one accident after propagation delay, but still A is transmitting, correct, because of minimum frame size. Now this collision will go back, right? So this collided bit will have usually more energy than actual energy signals possess. So that's why whenever A senses it back, already I told you one thing in CSMA CD, whenever you are sending the data, we have to sense the channel also. That's why. So your A is still sensing for collisions. That's why whenever that collided bit comes here, then energy level will be increased here and A might detect it. Understand? That's why we have to do two things at a time. Send the data, at the same time you should have sensing capability. It's a, I can say, simultaneous process. Okay, now we detect it. Once receiver detects it, then it will send jam signal. But before that, who detected it first? Assume that C doesn't have any data, D doesn't have any data, only A and B are having the data, they are sending. First time B will detect the this accident, right? So B can immediately send the jam signal. So why jam signal will be sent, we will see. Duration of jam signal typically will be 32 bit to 48 bit, okay, usually. So it depends on the standard, I can say, but let's assume that first of all, let's say it can be 32 bit or 48 bit. I will tell you what is standard size, but that is not important at this moment for you. So what is important for you is why this jamming signal. So that jamming signal generally will have unused pattern, otherwise it will have lot of energy level. That means the signal will have lot of energy. Because of that energy, so every receiver can understand that that is not a proper signal, that means not a data signal, it is something different signal. So that example, if jamming signal is detected, otherwise sensed by any station, they understand that it is jamming signal, then that means they understand that there is a dash, definitely collision, and they will stop sending. If they really have, they want to send, then immediately they will stop and they will wait for some time. Understand? So that's why jamming signal alerts all the stations who wants to send something into this channel. Okay, second thing, sometimes what happens, the real importance of jamming signal you can understand. Actually, according to the standard, they mentioned that jamming signal is for alerting the all other stations, but I will tell you the proper reasoning for it. That means more information I will give you now. So example, let's say collision occurs exactly here. Okay, now this signal is coming like this. Now here suddenly B started sending. Now whenever B sends first bit, by that time itself B will understand that there is a collision. Sir, whenever any station detects collision, what they have to do? Immediately they have to stop whatever they are sending. That means data sending should be stopped. Why? Why to send again and we have to create more collisions, right? That's why whenever B understand that there is a collision, then immediately it will stop. Maybe after one bit transfer or 2 bit transfer, it will understand it, then immediately B will send jam signal. What if B doesn't send jam signal? What is going to happen? We'll see. This is of course rare phenomena, but if there is a chance. So when there is a chance, then we will not be understanding the collision. Be careful. See the scenario. Let's say when collision happens at this point, by that time, so B is immediately recognizing it and it is stopping it. Then there is only one bit of B in the collision. Correct? Now you see. Assume that, let's say the time is 9 o'clock at that time where there is a collision. Now this entire signal is good. Only at this point there is a collision. Now that collided bit is going to slowly start propagating like this. Correct? This is a collided bit. Now see. So there is only one such bit. Now whenever that bit comes to this point, definitely it will have a different energy level. So A definitely can detect it. But sometimes what happens, though, with this small bit duration, your receiver might not be understanding that there is a collision, because collision should be detected by this bit, right? Only there is a single bit. By seeing the single bit, it will be very difficult sometimes for receivers to detect that there is a collision. I will give you one analogy. Example, let's say it's night, so completely dark, right? There is no power, nothing. Suddenly, so in your house, tube light started blinking. Just it got blinked only for 1 microsecond of time, but it happened. That means your tube light turned on suddenly. Then what happens? You will feel it, correct? But you will be in illusion, right? Really there was a spark or not, right? You can't really understand it. At least if the tube light turns on for 1 minute, let's say, then definitely you can ensure yourself that yes, there is a power, right? So again I'm telling, the analogy is, let's say night, and in your room there is no, there is no power, nothing. So it's a complete dark room. In the dark room, suddenly you have seen a light for 1 microsecond. Then you will be in illusion, and sometimes you don't understand that and you feel that it's just imagination, right? But what if that light sparks for, otherwise that light is for 1 minute or 2 minutes, then definitely now you will slowly get the confidence that, and you will detect it, that there is a light in the house, correct? So that's why in the same way, with 1 bit duration, your system A might not be able to understand the collision. Then there is a chance that A thinks it's a proper data transfer, correct? To avoid that, what B is going to do is, it is going to send jamming signal. What that jamming signal is going to do is, it is usually 48 bit. So that 48 bit jamming signal will go like this. It will have lot of voltage or lot of energy. So that jamming signal pattern will be different than original normal signals. So that jamming signal will have very huge energy. So that huge energy, whenever it comes to A, correct, definitely it comes right immediately. So whenever it comes, then if that huge energy is sensed by A, it will understand that there is definitely dash collision. So jamming signal really helps stations to understand that there is a collision. Understand? So this is a reasoning. If you don't understand the reasoning, still not a problem. Remember, according to the rules, whenever there is a collision, wherever some station detects it, it will send jamming signal, and the duration of jamming signal, otherwise length of the jamming signal is 48 bit according to standard. Okay, earlier it used to be 32 bit, so doesn't matter 32 or 48, whatever. Okay, in the gate problem sometimes they give you jamming signal and they say this is the length of the jamming signal. If they give length of the jamming signal, you should consider that. Otherwise we can use 48 bit. Understand? Now one more thing. So what is the duration of that jamming signal? If you see 48 bit, assume that it is 10 Mbps Ethernet. That means bandwidth is 10 Mbps. So really, to transfer 48 bits, how much time station is going to send? I mean take. I'm just calculating the transmission time of 48 this jamming signal. So 10 Mbps means 10 into 10 power 6 bits per second, right? To send 48 bits, how much time your transmitter is going to spend? So 48 bits, then dash time. That will be definitely 48 by 10 into 10 power 6. We know the formula directly, right? Message size by transmission bandwidth. So it would be 4.8 micro, see 10 and 48, 4.8 microsecond. So it takes very less time. So within 4.8 microsecond, all that jamming signal will come to the line and it will start going. Understand? So this is the story about jamming signal. And after that, what we are going to do is, once jamming signal is sent, now stations, other stations who have not detected so far the collision, they will detect it and they will stop sending if really they want to start. Okay. Now after that, so the station A detects it. Now it uses backup algorithm. That means whenever any station encounters a collision, that means whenever a station is involved in the collision, then its K value will be incremented. Example, let's say A is initially K value, you know backup algorithm, right? Every station will have K value like this, K. Example here, let's say C and D are sleeping, they don't have data. That's why they don't sense. That's why though you send jamming signal, they can't understand because they are not sensing the channel. Who can understand that jamming signal? Only the people by that time who are sensing. Now A and B, let's say currently have data. That's why only now when B sends jamming signal, only A can sense it. Now once A realizes that there is a collision, now immediately it will stop sending. Now it will apply, it will increment K value. Initially K value 0, then K value will become 1. That means A is using now backup algorithm. According to backup algorithm, A is going to draw a random number between what? 0 to, you know the technique, 0 to 2 power k minus 1, 2 power 1 minus 1. That means 0 to 1. One random number will be generated by A. Since B is also part of the collision, so B is also going to generate one random number. Assume that already B had one collision, just for understanding the things clearly. So B already got one collision, so by that time K value will become 1. This is the second attempt for one particular data. Then this time when collision happens, B also after sending the jam signal, it will run backup algorithm. According to backup algorithm, K value will be incremented. So now for B, K value is 2. Now I write here A and B. A's K value is, let's say 1 now. B's K value is 2. Now A draw a random number between 0 to 1. B will draw a random number between 0 to 2 power k minus 1, 2 square minus 1, 0 to 3. Already I taught you, backup algorithm, I am revising it. Now, example for, time being, let's assume that let's say A generated 1 random number, B generated 3. What is going to happen is, so there is a slot time in backup algorithm. So usually the slot time in this backup, Ethernet is 2 into propagation delay or otherwise I can say not 2 into propagation delay. It is usually, so minimum frame size transmission time. Otherwise you remember typically it will be 51.2 microsecond. Try to understand. What is the significance of this one? It is actually slot time. Otherwise transmission time of minimum frame. Correct? So this much time these stations are going to wait. We'll see how it is related to our backup algorithm. I will tell you. Okay, don't worry about how it is generated. Remember that in Ethernet usually back of time will be, otherwise that slot time is 51.2 microsecond. Now come back to our algorithm. K value 1, then 1 will be multiplied with that 51.2, right? So some random amount of time, I told you when I taught you back of algorithm, that random amount of time in Ethernet is usually 51.2 microsecond. Now for B it will be 2 into 51.2 microsecond. That means now A will try sensing the channel again after dash time 51.2 microsecond. B is going to start sending the data after 2 into 51.2, that means 102.4 microsecond. So A will be sensing first, after that B will be sensing. But you know one thing, before sending the data, definitely they should sense. If the station or sorry, this medium is idle, then only they should send. Understand? Now the final point. After the collision, they will generate some random numbers based on the back-off algorithm. Then that random number will be multiplied with slot time. Slot time in Ethernet is generally it will be it depends on the medium, everything, protocol, everything. For Ethernet protocol actually, so this slot time usually 51.2 microsecond. Now station A is going to wait for some its random number, let's say C. Okay, so A's random number is C into 51.2 microsecond, otherwise use C1. Now B's random number, let's say C2, then B is going to wait for C2 into 51.2 microsecond. After that they will start sensing it again. Understand? So this is about access method of Ethernet. Understand? Now let me consolidate. Ethernet uses CSMA/CD technique with one persistency. That means whenever there is when there is a data, immediately and they sense the channel and the channel is free, they send it. After that, this is the remaining story. Okay, one more important point about this backup algorithm, you see, consider the situation. There are multiple stations. Okay, let's assume that, let's say there are 50 stations and all are trying for acquiring the channel. Okay, so there is a collision. Now what happens then? Whoever is involved in this collision, let's say A comma B comma C comma D, their K values will be incremented by 1, isn't it? Then they will try to draw a number between 0 to 1. A will try 0 to 1, B will try 0 to 1, and C will try 0 to 1, D will try 0 to 1. Definitely there will be two systems who draw the same number, because there are only two possible numbers, right? So definitely there is a collision again, second time. Assume that this time the collision is between A comma, let's say B comma C. Okay, these three systems took same number. Then again K value will become 2, 2, 2. Then this time they try to draw a number between 0, 1, 2, 3, 0, 1, 2, 3 and 0, 1, 2, 3. Okay. So now what if two systems again draw same number, there is a collision. So in heavily loaded system, that means in a heavily loaded I can say environment, what can happen is one station might get always collision. First time there is a collision, second time there is a collision, then K value will be incremented. Initially K value 0, so again collision occurs, K value 1, again collision occurs, K value 2. So for same data packet I am saying, okay, so K equal to 3, K equal to 4, in that way. So when K equal to 10, what is going to happen? So it is going to draw a number between 0 to 2 power 10 minus 1, 1023, correct? So in that way it will be continuing, but the question how long it should continue. So generally there will be one threshold. So when K hits 15, then what we do is generally we report that error to the high level layer. That means we stop this procedure and we take appropriate action. It depends on the standard, otherwise protocol, whatever it is used. So that's why don't worry about that case. But just I want to inform that when K is 15, sometimes a station which is having lot of collisions for particular frame, that is going to hit, otherwise its K value is going to hit 15, then we stop. So when K less than 15, we continue this process. If K greater than or equal to 15, usually we stop it and we report the error. So there is something. That means otherwise the strategy is very simple. We should convince Mr. System A that, my dear System A, please wait for some time, because since after K equal to 15 also you should I mean why you got this number K equal to 15? Lot of collisions. Lot of collisions means so many people are trying channel. Don't try at this moment. You keep quiet. Your fate is not good. So after some random amount of time, so A is going to try again. That is the way we can plan it. That is about threshold. Understand? Now we'll see encoding scheme. In Ethernet, encoding scheme is Manchester encoding. Here we don't go into the details. We just need some information about this encoding scheme. That is, it is Manchester encoding. The specialty of Manchester encoding, otherwise one important information you should know about Manchester encoding is baud rate. So what is baud rate? First of all, I will tell you. Whenever you have a data, example zeros and ones, correct, that will be converted to signals, correct. So we say that these 0 ones are data elements. They will be converted to signal elements. So finally there are two layers, I can say, correct. In the data link layer we have data, of course in network layer everywhere, but if you see here in the physical layer we have signals. Every data element will be converted to signal element. Okay, that is about data element and signal. Now what is baud rate is number of signals per second which you are transmitting is nothing but usually baud rate. Number of signals finally per second. So what is bit rate is usually number of bits in the high level. So as a user, otherwise in the high level, what I think that I am sending bits, correct. So zeros and ones, how many bits per second you will be able to send through the communication channel is nothing but bit rate. Usually we talk about bit rate, that is important for us. How many signals are going to be sent doesn't matter for me. What is important for me as a high level user? Bit rate. So baud rate is related to actually bit rate most of the times. So for every bit you are going to send a signal, so number of signals per second also used to be equal to number of bits per second, isn't it? There will be one-to-one mapping. For every bit there will be a signal, then bit rate will be equal to baud rate. But in Manchester encoding kind of difficult encoding schemes, what is going to happen is to send one bit, so you might require multiple signals. That means two signals, let's say. Then if you want to send 2 bits 0 0, then you need 4 signals. Now we'll see what is a bit rate. Example, per 1 second you are sending 2 bits, then what is your bit rate? 2 bits per second. But to really send 2 bits we have to send 4 signals, then what is the baud rate? 4, correct, baud. It is actually 4 baud. Okay, so that means 4 signals per second. Understand, it is 2 bits per second, this is 4 bauds per second. Baud is nothing but signal. Understand? Now the relation between these two, if you see, bit rate here is 1 by 2 into baud rate, especially in Manchester encoding. Otherwise baud rate equal to 2 into bit rate. So that is the relation between bit rate and baud rate, especially in Manchester encoding. But it is not true in everything. So don't blindly take wherever baud rate is given, don't apply this formula. It is only for Manchester encoding. So Ethernet uses this physical scheme which is Manchester encoding for encoding. That, if you remember, that is more than sufficient. Now we'll see channel efficiency. Let's see channel efficiency in Ethernet. That is actually 1 by 1 plus 5.4a. Okay. So where a is nothing but propagation delay by transmission time. Okay, here especially transmission time is a transmission time of average packet. Okay, because in Ethernet you can have variable size packets, right? So let's assume that where this transmission time is a transmission time of a mean frame, that means average frame. Okay, so propagation delay is of course constant, right? Now this is the channel efficiency, but there are some other formulas also. 1 plus 6.4a, 1 plus 3.4a, in that way. So every formula is derived in a different way. Okay, different authors derived with different assumptions. So it's a controversial thing. So which one we have to use? So we can't decide. That's why don't try to decide that. So there are multiple formulas and each one because of some assumptions, and approximately all are same. Correct? There is a minute difference. Now second thing, in the GATE exam Definitely they don't ask question related to channel efficiency because of this controversy. Okay, they don't ask ambiguous questions, so don't worry about it. If at all if they ask in the gate questions, then go with this 1 by 1 plus 5.48. Okay, anything, not a problem, but 100% they don't ask. This is about Ethernet channel efficiency. Let's try to focus on this. So here, to get lot of efficiency, let's take this one and we try to analyze 1 by 1 plus 5.4 a, right? So this a is 0, then what happens? 5.4 into 0, 0, 1 by 1, 1. You get channel efficiency 1. That is what we want, right? But it is impossible. How can you make a value 0? It is impossible, but try to understand. When this a tends to 0, exactly 0 is not possible, but when a reaches to 0, to reach a value 0, propagation delay by transmission time should be 0, correct? So propagation delay by transmission time is 0 means, so this transmission time should be very large and propagation delay should be small. Then definitely, Ethernet will perform better. Remember it because of the formula, right? So if propagation delay is very small, it will be almost 0, let's say. Then definitely 0 by anything is 0. We can have that. If propagation delay is not 0, let's say it's significant, like something PD, okay, significant, but transmission time is very high, infinite, still you get channel efficiency 1. Okay. So transmission time depends on your bandwidth, propagation delay depends on the length of the cable, correct? Now I can say that for better performance, your Ethernet cable should be very small, that means length should be very small, otherwise bandwidth of that medium should be very high. If any one of them happens, then channel efficiency will be high. It will be optimal. Understand? So that is what I can understand with this formula. Okay.